once again to our Math 10 class. For today's discussion, we will talk about the general term of an arithmetic sequence. Have you ever wondered how are we going to find, say for example, the 100th term of a sequence wherein only 4 terms are given? That is what we're going to discuss today. Now, to determine the formula in finding the general term of an arithmetic sequence, we will use this example. We have the sequence 7, 10, 13, 16, and so on. Now let us study the sequence. We have 7, 10, 13, 16, and so on. Our first term is 7, so it will be called a sub 1 because the number or the subscript that we have here tells us the term number or the order of the number that we are referring to. So since 7 is the first term, it will be called a sub 1. Then 10, our second term, will be referred to as a sub 2. And 13, which is the third term, will be our a sub 3. On the other hand, 16 will be our a sub 4 because it is the fourth term. Now let us study these numbers. We will begin with 7 since that is our first term. Then we will proceed to 10. How did we get 10? Very good. We added the common difference, which is 3. So 10 actually comes from 7 plus 3. Then to have our third term, we have to add another 3. So that is 7 plus 3 plus another 3. The same goes for 16. It comes from 7 plus 3 plus 3 plus another 3. Now, if you have observed, all of them have 7s, right? There. And then, we added 3's to them. Like for example here, we added 3. The same goes here. We also added 3. But this time, we have 2 3's. So 3 times 2 because we have 2 3's. And here we have actually how many? Very good. We have 3 3's. Now, since on the first one or here we only have 7, it only means that maybe we added 3 times 0, right? And here, since we only have 1 3, that is 3 times 1. Now let's take a look at the patterns. We have 0, 1, 2, and 3. Here we have 1, 2, 3, and 4. So if we're going to determine the formula for the nth term of an arithmetic sequence, we will start of course here because they have the same value, a sub 1 plus, what is d? That is 3. So we will substitute 3 with d. How about this part? The number that we multiply to d. If you have observed, when your n is 1, this is 0, right? When n is 2, this becomes 1. When n is 3, the number here becomes 2. Then when n is 4, the number here becomes 3. What if your n is, say for example, 10? What do you think is the number that we're going to multiply? Very good. That will be 9. It only means that we are just subtracting n minus 1. So that is actually the formula that we are going to use in solving for any term of the sequence. That is a sub n is equal to a sub 1 plus d times n minus 1. So don't forget this formula. And what does it mean? Your a sub n represents the general term. So it can be actually any term of the sequence. Say for example, if you want to find the 20th term, you can say that n is 20, so that is a sub 20. And the formula for a sub n is equal to a sub 1 plus d times n minus 1, where a sub n is the general term or the term that we are looking for. A sub 1 is the first term. N is the term number or the order of the terms. And of course, as we know in the discussion about arithmetic sequences, D is the common difference. Now, let's use this formula in solving for problems regarding the general term of an arithmetic sequence. Let's go. For the first activity, we're going to have where is a sub n. So basically, we will just solve for the nth term or a sub n of an arithmetic sequence. Let's have the first example. For the first example, we have the problem, find the 25th term of the arithmetic sequence 3, 7, 11, 15, and 19. Now, remember that the formula is a sub n. Don't forget the formula. A sub n is equal to a sub 1 plus d, or the common difference, times n minus 1. Now, since we are looking for the 25th term, we can say that we are looking for a sub 25. Now, what is the first term in our sequence? That is 3. That is our a sub 1. What is the common difference? For the common difference, we can subtract any two consecutive terms. For example, 7 minus 3. That will give us 4. So we will replace d with 4. Now for the term number, since we are looking for the 25th term, we will substitute 25 to n. So that will be 25 minus 1. So our a sub 25 will be equal to 3 plus 4 times 25 minus 1 is 24. Of course, following PEMDAS, we have to first multiply 4 times 4, 4 times 24 rather. That will give us 96. Very good. And then add 3 to it. Therefore, our a sub 25 is equal to 99. So that's how we apply the formula in finding the 25th term of an arithmetic sequence. Now, can you do the second one? For the second problem, you have to find the 9th term of the arithmetic sequence with a sub 1 is equal to 10 and d is equal to negative 1/2. Okay, so this time we are looking for the ninth term. Therefore, that is a sub 9, right? So following the formula, a sub n, let's write it again, is equal to a sub 1 plus d times n minus 1. Our a sub 1 is, what is our a sub 1? That is 10. It's mentioned here. Plus, common difference is negative 1/2. Since it's negative, we have to put it inside a pair of parentheses, 1/2. And since we're looking for the nth term, n is 9 minus 1. So that's how we substitute if we are going to solve for a sub 9. Now let's solve. We have 10 plus 9 minus 1 is 8. Then we will multiply it to negative 1/2. What is negative 1/2 times 8? Or basically negative of 1/2 of 8. So that will give us negative 4. And then adding this to 10 plus negative 4 will give us positive 6. So that is the answer for our second example. Do you have questions? If you have questions, you can do further reading. You can click on the link that I will place below. Okay, now for the next set of activities, we'll call it Let's Work the General. Intriguing, right? So it's actually an activity wherein we will not just determine our a sub n or the general term, but we will use the formula in order to determine, say for example, d or the common difference, n or the term number, or a sub 1 or the first term. Okay, I'd better give you an example so you'll understand it better. Problem number 1. Give the arithmetic sequence of 5 terms if the first term is 8 and the last term is 100. Okay, following our formula, a sub n is equal to a sub 1 plus d times n minus 1. Take note, in this example, we have to determine the arithmetic sequence of the first arithmetic sequence of 5 terms. We already know the first term, that is 8, right? So we will be able to determine the next terms if we know the common difference. So for this example, we will solve for the common difference. Since that is missing, it is only the value that we will not replace with any number. So our a sub n, so that is actually the last term, that is 100. We will replace this with 100. Is equal to, what is our a sub 1? It's mentioned in the problem, that is 8. Plus d. We're looking for d actually. And then our n, or the number of terms, is actually 5 because we only have a sequence of 5 terms. So that will be 5 minus 1. Now, continuing further, we're going to have 100 is equal to 8 plus 5 minus 1 is 4. Multiply it by d. That will give you 4d. Now, following our different properties of equality, we're going to have 4d is equal to 100 minus 8, or 92. So 4d is equal to 92. If we're going to divide both sides by 4, d will be equal to 23. So that is the common difference. But that is not yet the answer. We have now to determine the sequence of 5 terms. So we will begin, of course, with the first term, which is 8. Then we will add 23. That will give us 31. Then another 23. That will give us 54. Then another 23. That will give us 77. And another 24. That will give us 100. See? The first term is 8 and the last term is 100. So that will be our final answer. You have questions about this? Okay, let's now go to the second example. So the second problem is, find a sub 1 if a sub 8 is 54 and a sub 9 is equal to 60. So using the basic formula for the general term, let's write it again. This is the hardest part actually, writing it. A sub n is equal to, do you remember? A sub 1 plus d times n minus 1. Sorry for my penmanship. Okay. Now, since we are looking now for a sub 1, that is only the value that we will not replace with any number. Now let's begin. Your a sub n will actually be your last term. In this case, that will be a sub 9. So we will replace it with 60 equals, since the first term is missing, we will just write here we go again, a sub 1, okay, plus, what is the common difference? How are we going to know the common difference? Since the 8th term, or a sub 8, is given, that's 54, and the 9th term is also given, that is 60, we can say that the common difference is actually 6, right? You just have to subtract 60 minus 54. And then, what will be our n? That is 9, because we have a sub 9 as our last term. So 9 minus 1. Okay? Then, we are going to have 60 is equal to a sub 1. There. Okay. Plus, what is 9 minus 1? 8 times 6. That is 48. So, if you're going to solve for this, we're going to have a sub 1 okay, is equal to 60 minus 48, or 60 minus 48 is equal to 12. Okay, very good. So our a sub 1 is 12. How are you going to check? You can start with 12. Common difference is, what is the common difference? 6. Okay, then you add 6. 18, 24, 30, 36, 42, 48, 54, and 60. Did you see that? We have how many terms? We have 1. That is the first term. 2, 3, 4, 5, 6, 7, 8. 54, that is our 8th term. And 60 is our 9th term. Okay, let's go to the next example. For the third problem, we have, how many terms are there in an arithmetic sequence with d is equal to 4, that is the common difference, and with first and last terms 3 and 59 respectively. Now, we are looking for the number of terms. So, if we're going to use our formula again, a sub n is equal to a sub 1 plus d times n minus n. We are actually looking for the value of n. So we will not replace n with any number. Okay, let's proceed with the solution. What is our a sub n? This will be the last term or the general term. That will be 59, right? So we will replace this with 59 equals, what is a sub 1? It is mentioned that is positive 3. And then the common difference is mentioned also, that is 4. And then we have n minus 1. So the first thing that we have to do here is to multiply 4 times n minus 1. So we will just copy this part. 59 is equal to 3 plus, what is 4 times n? So that is 4n. And 4 times negative 1 is negative 4. Okay, so we will combine now. 59 is equal to, what is 3 and negative 4? That is, okay, we'll first write 4n. What is 3 plus negative 4? That will give us negative 1. And then, we are going to have 4n is equal to 59. And then we transpose 1. 59 plus 1, that will give us 60. So when we divide this, it will give us a value of n is equal to 15. So meaning we are going to have 15 terms of a sequence. So how can we check? We can actually begin with, okay, let's write the sequence. Let's start with the first term, which is 3. The common difference is 4. So we will just add 4, 7, 11, 15, 19, 23, 27, right? Okay, 31, 35, 39, 43, 47, 51, 55, and 59. Let's count if we have actually 15 terms, because that is the answer that we obtained. According to our solution, we have 15 terms. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So that is our solution. Now guys, be one of our 2 winners for our giveaway question. All you need to do is to answer this problem. What is the 37th term of the sequence negative 17, negative 8, 1, and so on? Write your answers on the comment section of this video. Thank you guys and good luck. Bye!